Good morning, everyone, and welcome back to the fourth day of our faculty development program on blockchain technology and its applications, organized by the Department of Artificial Intelligence, PSIT Kanpur, in collaboration with AICTE Training and Learning Academy. We are delighted to bring in today's morning session with Dr. Urbi Chatterjee from the Department of Electrical Engineering, IIT Kanpur. Ma'am has a strong academic and research background with contributions in areas such as power systems, optimizations, and smart technologies. In today's session, Ma'am will be sharing her expertise and valuable insights that will surely enhance our understanding on the interdisciplinary aspects of blockchain and its technological applications. Now, I would like to invite Head of Department Computer Science, Dr. Nand Kishore Sharma sir, to present a token of appreciation to our esteemed speaker. Thank you, sir. Let's extend a warm welcome to Dr. Urbi Chatterjee, ma'am.
Hello, good morning everyone. Yeah, so this is my second time here. So today we are going to talk about definitely blockchain, but my main focus will not be on the technology itself, but rather a very niche area where blockchain can do wonder. Okay, so we will see that. Okay. So, my name is Urbi. I'm an assistant professor in the Department of Computer Science and Engineering, IIT Kanpur. And today we are going to talk about physically unplanable function and blockchain for IC supply chain management. IC means integrated circuit. Okay. So, anybody has any idea about supply chain management? What does it mean? You can raise your hand and tell me. What is supply chain management? No idea? Okay, very good. So, what happened? Everybody heard of Intel? Huh? Intel fabricate your laptop, right? Okay, so what happens is that Intel first create a design of the computer. I am talking in a very high level, and then we will go into the deep. Okay, so Intel first create the design. Sometimes they also collect some hardware from other vendors. Okay, when I say collect hardware from other vendors, collect hardware IPs from other vendors. Okay, IP means intellectual property. Okay, and then they create the whole design, and then they send it to a foundry where we actually fabricate the whole setup, and then through lot of stakeholder it comes to us. Okay, so the whole process of creating hardware or creating a integrated circuit or a chip or a PCB, okay, and the process through which it comes finally to us or to any end user, that is called supply chain. Okay, and there are a lot of people who are in this supply chain management system. Okay, here today the focus is mainly on IC management, IC supply chain management, and what are the perks, what are the security vulnerability that occur in this supply chain. Okay, so what happens is that in 2017, DARPA pegged the cost of almost 170 billion in lost electronic revenue. Okay, so there are people in this supply chain management who create fake ICs, counterfeit ICs. They replace new IC with old IC. They package old IC and remarked is as an old IC. And why do they do that? Okay, the basic question is why do they do that? Okay, can anybody tell me why do they do that? What you are thinking? What is the purpose of doing such malicious activity? Yes, generating more profit, taking advantage of certain situation. For example, suppose there are some legacy system where we use some ICs that are designed into 200 nanometer technology. Okay, now our system has advanced, but those systems are still in some infrastructure, and it is very hard to create an IC right now on that technology, 200 nanometer technology. So what these people will do, these attackers, they will create fake IP in the name of the company or the manufacturer and them sell them in the black market. Okay, so recently I was talking to a student about the same thing. One of our faculty member, he has a very big Sony TV. Okay, he bought it with more than 50k rupees, and then suddenly one small portion of the motherboard which is there inside the Sony TV, it got corrupted. Okay, so he called a local supplier or local electrician, and he said that कैसे करवाना है? So he asked, what do you mean by kaise karwana hai? He said, if you send it to the real Sony service center, they will take 20,000 rupees. So the cost of your TV was 50,000, and just for a small chip you are going to give 20,000 rupees. I can do it in 4,000, 5,000. But I cannot guarantee how long it will go. Okay? So somebody can say, no, I will choose the 20,000 rupees IC. And if someone has really, like, somebody needs that TV very urgently or does not afford, then they will go for this 4K, 5K solution. And you can understand then that's the chip that they will put into in that 4K, 5K rupees setup will not be a original IP or original IC. That will be either a counterfeit IT or something related to that. Okay, so even before pandemic, there was a severe shortage, okay, in the market for ICs, such as in automotive and appliances, particularly for chip manufactured at matured node using 200 millimeter technology. This is exactly what I have said. Okay, so nowadays any cheap design companies, they actually own the technology. Like 28 nanometer is owned by, suppose, Cadence. 60 nanometer is owned by Synopsys. Have you heard of these companies, Cadence, Synopsys? Some of you have used, right? We will tell what kind of company they are. Okay, so they only can create chip in that particular technology. Okay, nobody else. If somebody is doing that, that means they are doing it illegally. So today we are going to see how blockchain can help us in stopping this illegal activity. Okay, so so as I said, counterfeit IC can be of different type: recycled, cloned, remarked, overproduced. Suppose I have sent the netlist as a manufacturer, I have sent the netlist to a foundry where we actually fabricate chip and said, okay, give me 20 million chip. What they will do, they will create 50 million. Then they will send back 20 million, 30 million they will sell in black market. Okay, so this is what we called as overproduced, and then there are something called forged chip. We will see today the examples. Okay, so Professor Mark Taranipur from University of Florida, he's a like a very well-known personality in hardware security and trust. He always said that, you know, whenever there will be a chip shortage, the black market of chip supply will rise up. Okay, they will try to meet the user demand and sell bad chip in higher cost. And that is true for any other supply chain. Okay, so even if you remember during COVID, when people were not getting food, the price of rice, price of, you know, pulse, okay, 80 rupees per kilo stuff was getting sold by 200 rupees per kilo. Same thing, same psychology. Okay, so there was a famous case in 2011 where a woman was sentenced to 3 years of prison, okay, for importing counterfeit integrated circuit from China and Hong Kong, and then they were selling to US Navy and defense contractor. Okay, by saying that it's original chip. Okay, so the problem was that the organization that she led was falsely marketing the product as being military grade. Okay, so we can have lot of encryption solutions. Okay, when we deploy it for user, they will be different. When they will be deployed for a military application, they will be different. Okay, so this became the first federal sentencing for trafficking counterfeit ICs. Okay, and it's still going on. It's still going on. So then, what are the supply chain insecurity? How people, adversary or attacker brings insecurity in supply chain, specifically IC supply chain. What they do is that they take an old part of an IC and then mark it with current data code. That means giving a new timestamp, although the code, although the IC is actually old. Okay, sometimes, yeah, the incident that just we talked about, they actually change the marking for upper grading, like making for like civil use to military use. Okay, then they remark failed real part. Okay, so whenever we create IC, we actually fabricate them in bulk. Okay, so sometimes what happens that some chip may have some faulty part. Okay, as a user, you or me cannot understand. So what these people do is that they say that this faulty IC has passed the test. Now they are sold, they are put in a laptop like this, but the laptop when it will come, it will not work. Okay, so this slide is basically where the adversary can sit in the supply chain. Okay, now the fourth thing that they can do is that suppose a particular die has been removed from packaging and then repackaged by some additional circuit in it. Okay, and then remark to the device which is in the demand. Okay, so among all the counterfeit components we just talked about, 80% are recycled and remarked. Okay, there were a picture in Twitter. It was it became very famous in China. Some journalist had taken a picture of dump yard of ICs. They are washing those IC with water, and the target is that they will use them later on in some other product. In China, there are fake Apple stores as well. Can you imagine? Okay, so after that we had clone parts, cloning, IC cloning, which are produced by an unauthorized producer of the part without having legal IP right to produce those IC. Okay, and then sometimes we tamper some part of the ICs. Okay, which will possibly include something called hardware Trojan. Have anybody heard of it? Hardware Trojan is like a malware. Software malware, hardware Trojan. The only thing is you can delete the malware, hardware Trojan will remain there. Okay, so the tamper component can potentially leak valuable information of the counterfeit. Okay, so now see, these are some pictures. So the left one is false chip, and the right one is the correct chip. Okay, so it's a counterfeit electronic component. The difference in the font, the printing, the text size is a sign that the IC is counterfeited. Okay, so there are some sanding and reprinting part that has happened, and the people who are working on hardware trust, they can find it out. You and I, we cannot. Okay. Then there is another very funny thing that the attacker did. They took an Intel chip and remarked it as an AMD chip and selling it as an AMD processor. Can you imagine? Okay, so then sometimes what happens that if some wire bond is defective, you can see there are two wire bond. After the wire, there are two round part. So if it was a genuine one or the correct or fault-free one, people has discarded it. But what they have done, they have just added another wire ball and then connected the wire. So this is how they counterfeit IC. Some more example. So this is two different chip, which is basically analog to digital converter. One is monolithic 8-bit video converter, one is high-speed 8-bit monolithic digital converter. Okay? So these are the numbers of the chip C9048, B9002. Both of them will work mostly same, just little bit of degradation in the performance. So very close substitution that they are doing. Similar function, 8-bit analog to digital, same manufacturer, little bit difference in pin-out variation. So again, if you use this for analog to digital converter, sometimes you might get good performance and sometimes it might not get a good performance. But as a normal user, we cannot understand. And that's how, that's in a very minute level, people do adverse attack in the IC supply chain. Some more example. So you see, this is from Honeywell, where they have found counterfeit, where they have added some fake plating on the leads. Okay, this extra leading that is there in front. Okay, this golden one. Can you see it? Okay. Then there are some residual material on the leads. The left one is the tampered one. See, there is a difference between the left pin and the rest of the two pin. Right? Then there is remarking. Little bit white shade you can see in the screen. That was the original marking. They have used chemical to remove it. And then on top of that, they have given another mark. Okay? And then heat sink mark on the package. Some fake IC they have taken and then they have packaged it by naming Intel Pentium. But it's not an Intel Pentium chip. Understood the problem statement? क्या solve करने का कोशिश कर रहे हैं हम यहाँ पे? ठीक? अब देखो. So there are a lot of way we can find whether there is a particular IC is defective or not. There are a lot of electrical tests, there are a lot of physical tests. There are many microscopic, there are many tests where we use microscopic camera to check whether there is any fault or not, whether there is an electrical fault or not, and that may help us to understand that a particular IC is counterfeit or not. Okay? Even, so the literature is quite rich right now. Even, so NIST also developed a way to insert aluminum atoms few nanometer into the silicon to create a novel ID tag. Okay, so that when we probe that ID with radio wave, it will produce a unique response. So attempts are there. Okay, at detection level, that whether there is any defect in the ICs or not, whether this, sometimes we also add a unique identity to a particular chip. Okay, but then see this. This is the condition. Now we know hundreds of names. These all companies are related to my hardware fabrication. So so we call it as value chain. Okay, there are companies which is actually doing fabulous chip design. For example, NVIDIA, AMD, Qualcomm, Novatech. Then we have foundries who actually fabricate the chip. For example, we have TSMC, have you heard of? The Taiwan very famous company. Their perfection is awesome. Okay, so TSMC has their own foundry, Samsung has their own foundry. Then we have certain company who just does the testing and packaging. So one malicious entity in that company, your whole supply chain is okay, but when the chips are coming, one bad person in the testing company can jeopardize your whole procedure. Right? Then we have companies which create CAD tools, computer aided design tools for hardware. So there comes synopsis, cadence and all. So they create an ID in which you can actually design your hardware using a software. So you really do not need to place the ICs one after another, connect them, input, output, and check the final value, okay? Then there are some manufacturing or assembly equipment. Intel is, I think not, Nikon, ASM, they actually supply material for fabrication. Then we have integrated device manufacturer like Samsung, Intel, Micron, and etc. So we will just go through few of this type of companies, okay? For example, first there are semiconductor equipment manufacturer. They design, produce and sell machinery and tools essential for semiconductor production. Now, if somebody gives a tool which is already faulty, or by default it is inserting a hardware trojan in your design, once you are creating the netlist, you cannot do anything. Okay? So, suppose I am in Intel, I will use this tool to create my own design, but the moment I will generate the netlist, something extra will add up automatically. Attack in supply chain. Okay? Then comes electronic design automation companies, which provide tools, technique, methodology for designing and producing electronic system. Suppose you are going to create an electronic control unit for automotive, car dashboard. So these software tools will be used by you. Okay? Foundry companies, where we basically manufacture the IC. Okay? So instead of designing their own semiconductor, these design firms hand over their design to foundries, which then turn this design into physical chip. Okay? Then we have fabless semiconductor company. They have nothing to do with foundry. They just create the netlist and send it to the foundry. Okay? Then we have integrated device manufacturers like Intel. So they handle both their design and the foundry. Okay, in this kind of company, it is safer because they have their own foundry. Okay, but insider attack may happen. And then finally, we have outsourced semiconductor assembly and test companies who specializes in providing third-party packaging and testing services to semiconductor manufacturing. Okay, so they actually use all this input, output to a particular IC and check whether they are giving correct result or not. And if there is a fault or if they lack in testing it rigorously, then there is a chance that any counterfeit IC will get away with it. Okay. So now, where we need blockchain or where blockchain can help us. Okay. So this is the IC supply chain flow. First we design, then we synthesize, then we verify that our code is functionally correct or not, then we fabricate the chip. Okay. And then we test the package and we do distribution. In most of the cases, the counterfeiting happen in these last two phases. So, we propose a work. I think I shared that paper with all the faculty members few weeks back, which we are going to discuss in the research paper discussion phase. So, I'm going to explain that work only here. What we try to do, can we automate this transfer of IC among different suppliers or stakeholders in IC supply chain management system using blockchain? Can we automate it? Right? So, this is the purpose of the tool that we are going to talk about. So, here basically two cryptographic component that is going to be help us. One is definitely blockchain, but to authenticate the IC, we will use something called a hardware fingerprint of a device, physically unclonable function. So what is the main crux of it? Suppose there are 4 ICs. See? You can see 4 ICs over here, right? The main crux of PUF is that if I give same challenge, the response will be different. So just think, suppose I have a AND gate. I give 0, 0, 0, 1, 1, 0, 1, 1. I will always get 1 for 1, 1. And always get 0 for the rest of the combinations, right? But that is not the case here. So here the truth table is device specific. Now can anybody tell me how it can help in detecting counterfeit IC? कुछ तो बोलो, don't be silent. So if I have two chip, one is counterfeit, one is real. As a verifier, I can send a challenge to them. Now, if the counterfeit IC is trying to fake a real IC, what will happen? Will the response of the puff match? No, right? Okay? So that is the main crux. You can remark, you can change some part of the chip, but you cannot change the nature of a hardware. Okay? So suppose my name is Urbi, and what's your name? Tejaswini comes today and tell my student, hi, I am Urbi, in a call, right? So my student will immediately pick up. They will say, no, your voice does not match like Urbi. So my voice, my thumbprint are very much physically unclonable from Tejaswini's voice or thumbprint. Right? So even if you remarked and try to make it enter into the supply chain, you really cannot fraud its fingerprint. Right? So what people are proposing over here is that, mota mota ye baat hai, whenever we are going to create some real IC, real good IC, we will send some challenge to the PUF circuit which is associated with that IC. So in the IC, I will have the real functionality as well as I will have a small hardware circuit, digital circuit, which will act as a physically unclonable function. Okay, so you can have multiple IP with same functionality. I can have multiple laptop of same functionality, same specification, but a PUF circuit here will have a different behavior from PUF circuit in another laptop with same configuration. Okay, so quickly let us see this metric, because tell Dipesh to explain in the demo part. Okay, I'm just going to let them understand that how actually the PUF works. Okay, so what we do in a hardware, we create this n-stage symmetric delay chain. Okay, just look at this. The main crux is that I will trigger the signal. This red signal is a trigger signal. You understand, in both input we are sending the same signal, right? Now, given the challenge is 0, the signal will pass straight. Given the challenge is 1, they will cross the path. Okay, so given a challenge, the trigger signal will propagate from input to output, but depending on the challenge, either they will contribute to the lower output or the upper output. Is this clear? Okay, so now the main crux of PUF is that all this propagation delay of this 4 path are unique to a particular hardware. Nobody can replicate it. So in an AND gate, if I give 1, 1, I will always get 1. But depending on different fabrication of the AND gate, how much time it will take to generate the 1, that is unpredictable. So this is what we call as propagation delay. Okay, understood? So now, what I am doing over here, I am, along with my whole functionality of the chip, I am also implementing this design. So I trigger the signal, give a challenge. For example, there are 64 such stages, so I will give a 64-bit challenge, and at the end I have a, what is the last component in YOLO? You guys are from computer science department, right? Computer science electrical. D flip-flop, exactly. So what it will happen, what it will do is that both of them will get logic 1 only, but depending on the delay, either D input will come first or the clock input will come first. So if D input come first and clock then sampled, output will be D, that is 1. But if clock signal comes first and D is not yet arrived, it will sample, output will be 0. Right? So it is not basically following any logic. It just depends on how the signal propagate through the stages of the arbiter puff. And that creates a signal exactly like the way I show you the, the radio wave fingerprint, right? Which NIST has proposed. So this can also work as a hardware fingerprint of your IC. Now quickly see how we implement that stage. So you see, we take, in every stage we take two 2x1 multiplexer. Okay? So I will just put down the phone, microphone right now, because I have to, am I audible? Okay. So what we do over here is that I'm giving the challenge. Input is a figure signal, right? Now you see, this is symmetric line, right? This part and this part are symmetric. This part and this part are symmetric, right? So I give the select line of the multiplexer, both of the multiplexer, in such a way that if the challenge input is 0, the trigger signal will go like this, and the trigger signal is 1. The challenge signal is 1. The trigger will go this and this. Okay, so they are symmetric in nature. But even if the lines are symmetric, there will be difference in the propagation. Fine. So this is one way of creating puff. There is another way also by using ring oscillator puffs. Okay, just a second. Just a second. Yes. So here what we do, now assume a NOT gate. If you give 0, what will be the output? 1, right? I have added 5 NOT gate one after another. If you give 0, what will be the output? 1. So given 5 NOT gate connected one after another, and given 1 NOT gate connected one after another, functionality is the same. What is different? Propagation is different, right? So now what we are doing, we are creating something called ring oscillator. What we are doing, we have odd number of inverting gates, right? And then we are giving 1 over here. So what will happen? After certain time it will give 0, then the signal will come back, and here the input will be 0, then I will get 1. So it will oscillate between 0, 1, 0, 1, 0, 1, 0, 1. But if I have n such similar structure, as I said, propagation delays are different. So the oscillation frequency of n such ring oscillator will be different. And again it is unknowable. So what we do in ring oscillator puff is that I have n oscillators, okay? And then I create a multiplexer of size log n to the base 2 plus 1. ठीक है? तो ये क्या करता है? These two multiplexers select 2 among n oscillator and then make them drive 2 counters. You know what is counter? Counter पता है? Count is a T flip-flop. Exactly. So it counts 0 at every clock cycle. It will count like 0, 1, 2, 3, 4, 5, 6, 7 up to the power n minus 1. It's the n bit counter. Okay? So what we do? We trigger the ring oscillator and let them drive 2 counters. So the value of the counter will change depending on how frequently they are changing. The oscillators are changing 0 than 1. So agar at a key time step I stop, do you think the value of the counters will be same or not? Same होगा? नहीं होगा, क्योंकि वो फ्रीक्वेंसी तो अलग है. तो अगर मेरा ये काउंटर का वैल्यू इस काउंटर से ज्यादा है, तो I will take response bar. creating puff, and we can actually integrate this chip inside any other chip. And then what happens is that, suppose for example, let's take an example of a aged IC. IC बहुत पुराना हो गया है और उसको फिर से सप्लाई चेन में कोई डालने की कोशिश कर रहा है. Depending on how many times we have used this ring oscillator, then their nature gets changed. It depends on the pressure. It depends on how much old the IC is. It depends on the temperature. Okay, so if we have a model for a real IC, that how these ring oscillators are going to be behaving over time, and then they behave like an aged IC than a real IC, can I find out that it's a counterfeit? ठीक है, तो तुम ऊपर कितना भी लेवल डाल दो, वॉल चेंज कर दो, हाँ कुछ भी कर दो. The inherent property of the hardware you cannot change. So people has used to authenticate an particular IC this puff technologies. Okay, we will show a demo of this today. So now you can see that this is how, for a given set of challenge in different hardware, the signature of the puff responses are different. Okay? So now quickly I will. So how do we do authentication? When I am creating a puff, I give a set of challenge, get a response, save it in a database. And then when it is deployed in an insecure network, I give the challenge, get the response and match it with the saved ones. Now I have to protect this challenge response pairs. Nobody should modify it. Okay? Here comes the role of good. So how can blockchain helps us in counterfeiting? Just a second. Let me see. Okay. So it helps us in providing transparency. Whenever one stakeholder is getting hold of a set of ICs from another stakeholders, use this puff challenge response to validate them and then log the activity in blockchain. Okay? Improved traceability. I can trace my ICs because now they are marked. Okay? Increased efficiency. Everything can be automated. Okay, I don't need to go and check यारे उसका mark क्या था, वो पहला का marking है, पुराना marking है. No, every IC associated with the challenge response pair database, anybody, any stakeholder in the supply chain can verify them. And of course, stronger security. So, ये थोड़ा text है, skipping. I will share the slide, you can check it. So now let's go to the basic model. We are almost at the last part of the talk. So what happens in automatic authentication with PUF and blockchain? I have few trusted authority. This is my root of trust, okay. So here we have IP owner, original component manufacturer and all. And then there are peer nodes who are not trusted, but they can only use the challenge response pair database. If they try to change in the challenge response database, then the trusted authority can actually पकड़ में आ जाएगा वो, ठीक है. तो who are they? They are the PCB assemblers, integrator, distributor kind of thing. So the trusted party has the access to the PUF characterization and they can only write on the blockchain using smart contract. And what this peer node can do, they can do the authentication, they can do the ownership of the IC, transfer ownership, device information they can get, and they can trace and change the ownership of the IC. ठीक है? तो अब हम लोग क्या करेंगे कि here we achieve that the peer node can directly authenticate the electronic devices. We have a permissionless blockchain that allow the chip information available to all the nodes. Okay, everybody can see it, nobody can modify it, and then we can do the manual collection of the CRP and the chip information from the blockchain. And IPFS, have you heard of this interplanetary flight system, right? So this is in unmodifiable database, okay? So we store this challenge response pair databases in the IPFS and we use the hash of it to be stored in the smart contract. So at any stage during authentication, the peer node will get the challenge response pair database from IPFS, but they cannot modify it. That's our target. Okay. So why do we need that? We have discussed a lot, but still we can add an extra trust without relying on any third party for authenticating the device. The integration through blockchain resists any alteration of the data or information, does not allow manual intervention during CRP collection and authentication. So automatically they can download and do the authentication. Okay? Now this is how my flow will look like. Okay? Again I will go there.
Registered, okay, and then this registration will also be going into the smart contract, so that nobody later can say, "अरे मेरा तो हुआ था पर दिख नहीं रहा, मैं तो legal हूँ पर you are basically illegal person." Okay, now they will do the same thing for cheap enrollment as well. Whenever they will get it from the foundry, they will enroll the top challenge response pair for every chip. Okay, then they will create a hash of it. The challenge response pair table will put the IPFS, hash will be made, and इस time में इस chip को मैंने register किया, ठीक है? Now it is changing it for the distribution, ठीक है? और जो पहला वाला flow दिखा था, problem ज़्यादा आता है जब हम लोग distribute करते हैं, because then it is going out of the hand of the manufacturer, it is going to delivery partners. Now they can recycle it, they can forge it, and many other things that they can do, ठीक है? Now suppose from one clear node, I am doing the ownership transfer of the ICs. So what these two peer node will do? First, the peer node is taking the ownership of the IC. It will go to the IPFS. It will give the number of the IC, link with the CRP, and do a immediate hand-in-hand authentication from the previous peer node. Okay. As I said, because the hash of those challenge response pair are already registered in the blockchain, it cannot modify it, right? So then, if the chips are authenticated using the challenge response pair, they know that it's authenticated chip. It is not also overproduced chip, because overproduced chip's path has not been registered, right? It is not an old chip, because then the nature of the path will change and it will be found out, right? So if all the chip has done the challenge response pair authentication correctly, then only this peer node will take the ownership of the chip. Now once they have taken the ownership of the chip, the previous peer node was like, up to mere haath mein nahi hai, because I have done the authentication successfully. Now the owner goes to the current peer node. Okay, so now when he has to send it to the other one or to the user, first it will do the authentication again, and then that transaction, like this authentication has been done, and the chip has been handed over from this peer node to that peer node, will also go into the blockchain, right? So the combination of PUF, blockchain and IPFS, advantage क्या है? वो authentication goes automatic. It does not depend on mere, PIN numbers, marking and all, right? My blockchain is not overloaded, क्योंकि challenge response database blockchain में नहीं रह रहा है, it is in some database, and everybody can do a consensus on that authentication algorithm. वो ICM supplies में जहाँ जाएगा, वही challenge response pair database में जाएगा. ठीक है, you don't have to generate new and new, right? So this is the main concept of how PUF or any kind of fingerprinting operation along with blockchain can save us in attacks in the IC. This is the main.
Yeah. So
There are some results. I'm not going to talk about them today. Or later on I can show you, but there were a lot of, and this whole code is actually in GitHub. You can refer to the paper as well if you want to run it through. But today we will show how to create a blockchain for this ownership transfer as well, and also show something related to PUF as well. So here, one thing I want to show you that there are three more people who have used blockchain before our world to enable IC testing, but they did not have this PUF flavor in them. So as you can see, all authentication can be done by every stakeholder. Okay, it is not depending, it's not a centralized authentication, right? Then the interface is automated. Everybody can come to the same interface and do the authentication. And then the blockchain storage is very, very low because I am not saving any information in the blockchain other than the activities. Okay? So the three slides that I have skipped, I will come back to them when we are going to discuss the two research papers. Okay? So what is happening over here is that blockchain is giving us a massive cost saving. We can actually counter and against counterfeiting, and then the effective computation time for authentication and transfer of ownership of the IC gets reduced. So there are some news articles which I have used to create the PPTs. You can also go through. So Raju, you can start now. That is Dipesh. He's outside? Okay. So I have a quick meeting with Indian Army. I just have to give a presentation now. I will just come back. They will show you how to implement it. Okay? Just I am coming back in 15-20 minutes. Sure. पहले डॉक्यूमेंट समझाओ फिर आराम से यूनिफॉर्मिटी यूनिटनेस और रिलायबिलिटी क्या होता है तो आपका वो समझाना शुरू से ठीक है फिर कोड and also show them the code for blockchain.
Sure. Okay, so do we proceed for the class? We'll have 10 minutes break and we'll listen to the break.
Students will be sitting here only.
So, ma'am, then I can continue with my interaction with students.
Yeah, sure.
इसकी मुझे जरूरत नहीं पड़ेगी। अच्छा, you're recording it. Sure, sure. Let's go.
अभी ऑन है बंद कर
That is that छोटे क्लास स्टूडेंट्स आते हैं तो ये आने जाएगा
वही देख रहे हैं
नहीं तो आप वीजे लगा ये लगा दीजिए
विजय है
So while there was break, I was interacting with all the students. So we have the target audience is from UG second year till I think PhD students, right? And few students are new and few students are old. So old in the sense that how many students are there who have been attending this FDP since the first day? Can I have show of hands? Okay, okay. And okay, thanks. And how many students are new here? Like for the first time? Okay, the front benches, very good. So if whatever I say, if you people understand and you people take it home, then I will think that I have achieved my aim. Okay. So now, since this lecture is going since last 4 days, you all must have some idea regarding blockchain, right? Am I right? Some idea what blockchain is? Some blocks connected together. Okay. Do we know what is a hash? Yeah, what is a hash? Somebody just anything about hash. What is a hash? Address of the block. Okay. Somebody else? Yeah, please. Okay, ठीक है. Integrity of the data. Great. Somebody else? Yeah, please. Okay, ठीक है. So you have a fair idea. Am I audible since till the last? Okay, ठीक है. So what is a hash? I will reiterate. Whenever I have a data, I have a text. Say suppose the text, I have a text of 10 lines, 100 characters, or I have a book. I will pass those characters in a function, hash function, and it will give me a fixed length of output. Am I right? Am I right? So hash is such a function. If I give 10 characters, it will give me a fixed length of output. If I give 100 characters, it will give a fixed length of output. If I pass an entire book to the hash function, what will it give to me? A fixed size of output. So, and that there are some characteristics of hash. Okay, firstly, for any text, if I hash it, the result which I get is unique. Okay, even if I change a single dot in that text, the hash will change, right? Okay, so if I have a book and in that book, from the last page and the last dot, if I remove and I recalculate the hash, will the hash be same? No. So we are on the common platform, we know about hash now. Okay, okay. So hash has one more property, that it is a one-way function. What is a one-way function? Yes, you please. Yeah, correct. So if I pass the text, जिसका मुझे hash निकालना है, if I pass that text to the hash function, it will give me a hash. But if I pass that hash to that function, it will not give me the cipher text. Okay, so if I have a hash of a block in a blockchain, I can't find that what is there in the block. Can I find it? No, I can't find. Okay, so I'm feeling very happy that we are on the common consensus regarding the hash. So I will show you a small demo of blockchain. It will be a very small demo. Few of the blocks connected together, few of the hashes shown in each of the blocks, what is there in each of the blocks, so that at least the second year UG students can take something home. Okay, am I clear till now? Am I clear till now? Any questions till this part? Okay. So before I proceed with my demo, I'll just build up the stage for demo. Okay, build up the stage means that say suppose there is a company. That company is manufacturing smartphones. Okay, that smartphone will have say 1000 components, and those components when that smartphone, and for the company will manufacture a smartphone consisting of 1,000 components, and it will manufacture, say suppose 1 crore of mobile phones, or say suppose 1 lakh of mobile phones, or say suppose 1,000 mobile phones. Okay? So 1,000 components, 1 lakh mobile phones. The company will maintain a ledger. What is a ledger? Some bookkeeping work is being done in the ledger. Ledger means that a record book. Okay, a record book. So I will maintain the record book. In that record book, I will have record and entries of all the small minute details about one mobile phone and the 1,000 mobile phone which I have produced. Okay. Now that mobile phone has gone to a customer, and as a customer I have used it and I am facing some issue in that, and I go to the service center. Okay. And the service center guy tells me that probably your Wi-Fi module is faulty. So he will replace it. And also to keep an account of it, he will enter that thing in his ledger. Ledger means in the record book that so particular mobile phone of this customer in this part has been changed. Say suppose this service center is not an authorized one. Okay. And tomorrow again I face issue and I go to the authorized service center. He will be able to tell me that you have not put in a genuine part. Even if that genuine part had been procured from that same very company, like ma'am told that it can be outsourced from somewhere else. So from even if it is embedded in that mobile phone, it can be, we can tell that it is not the same because the ledger of the company is telling that you have not got this Wi-Fi module from us. Okay, understood? But what if I manipulate that ledger? Okay, so when we have physical systems and when we have electronic systems whereby it is not using some hash or some protection is not there, so that is prone to change or prone to counterfeit. Okay, we can change the ledger. So blockchain helps us to make a immutable ledger. What do we mean by immutable ledger? One person, yes, you please. Cannot be manipulated. Or if manipulated, I can find out that yes, the manipulation is there and the system has gone into the jeopardy. Okay, am I correct? Okay, now, so for ease of understanding and better assimilation in this demo, what I have taken that I have thought that the company has manufactured only one mobile phone and one mobile phone consists of 5 parts only. Okay, and we will see a small ledger using this blockchain of one mobile and 5 parts of it. It can be easily scaled up to thousands and many more parts and mobile. One more thing, you know, blockchain is a I say it's a tool, it's a technological tool to protect you from these counterfeit and everything. It's not a database. What do you understand by database? Collection of data where I can actually dump lot many data, TB, terabytes and petabyte, exabyte of data I can dump. So if the company has a record of 1 crore mobile phone, 1,000 parts, will the company be storing all those entire database on each block of the blockchain? It can store, but the blockchain will become heavy. It will actually defeat its purpose. So we will store the ledger in the database, take a snapshot of that database, calculate its hash. Okay, store that hash where? In the blockchain. So at any point of time, I am in a company and I want to manipulate that ledger, its hash will change. Are we clear till now? Any doubts? Okay. So with this pretext, I'll just start this small demo. I'll keep you explaining as in when I'll just is it visible to everyone? Okay, so I have actually made a small code in Go language, and I have not published it for the enterprise level because I just need to give a demo to you. So it is just a code. What do we, if we code for a blockchain, what do we call that file? We call it proof of work. Yeah, proof of work will come later. It is something consensus algorithm. We will talk about it. But it is something someone there said chain code. So we call it chain code. So I have deployed one chain code, a very small chain code. I'll just show it to you. Okay. So now in this demo, I have already registered 3 organizations. Okay. The 3 organizations is from the same company, and all the 3 organizations to start with are having same ledgers, same copy of the ledgers. So we start from this point of time. I give it to you. I tell you that at this point of time, the ledger is not manipulated because we are starting right now. Okay. So it says when I start my blockchain, it checks the integrity of the database. What does it do? Checks the integrity means that at this point of time when I'm booting up, I'm starting my blockchain, the previous blocks which were there in the blockchain, are they compromised or not? So it checked, I have started, it checked, it says integrity checked, passed, all ledgers are in sync. So presently all ledgers are in sync. Actually it is cutting some part of my window, but these are the choices which I have included. So first is, you can see register organization, register viewer, deregister organization, deregister viewer, show registered user, add update inventory, view blockchain, and exist. So I will go to, firstly I'll see show registered user. So I enter choice number 5. Yeah, so it is showing warehouse, master ledger, and mother hub. These are the 3 organizations which I have already registered. So a company is having some warehouse, a company is having some master ledger, and a company is having some mother hub. Okay, so they all are having ledgers and it is in sync. Now and viewers are 0 because this is viewers and there are no viewers. So let me also register one viewer now. Just a moment. Okay. Now is it visible to everyone? Okay. So now I enter choice number 2 to register the viewer. Viewer name says suppose customer 1, and I have registered it. Now I will add something to the inventory. Okay. So let me say suppose I have sent my mobile to I have gone to a service center, and the service center guy says that your mobile is faulty, let me send it to the mother hub for repair. So it goes to the mother hub. Mother hub says that Wi-Fi module has to be added in it. So I come to the mother hub. The mobile is there with the mother hub, and यहाँ पे मैं इसमें Wi-Fi add करूँगा module. So add and update inventory 6. Okay. Now when I see, now I will as a mother hub, I am a person sitting at the mother hub. I am authorized to enter in the ledger. Okay, if there would have been a graphical user interface, I would have had a username and password जिसको मैं enter करके I could have gone to the ledger. I have not shown the user UI, so you can build up your UI upon it. ठीक है? So now I am adding that Wi-Fi add enter quantity 1. Okay, so it is now asking me, it is now proposing this update. Now here is a catch. I just cannot update something in the blockchain. What I want, yeah, somebody said something that is right. What needs to be done? Everybody needs to be on the same board to add something on the blockchain. What is that word called? Not from you. Somebody there also said something. It is consensus. Okay? Yeah, consensus mechanism. You people understand consensus? You understand? Great. You people understand consensus? Okay. So what happens when I try to add something to the blockchain? There are 2, 3, 4, 5 n number of people in the organization who are authorized person to vet that okay, this addition, this entry from this very person is legitimate, and let us add this thing to the blockchain. Now there are 10, say suppose there are 10 of these people who are authorized to say that this should be added to the blockchain. So this copy, this proposal, that organization mother hub is adding a Wi-Fi to the ledger in so and so mobile will be proposed to all those organizations, and all those organizations will vote. Okay, they will vote for it. That okay, this is legitimate. Okay, yes. And if they are in common consensus, that block will be updated in the blockchain. Okay. Any doubt still no? Any doubt still no? Okay, so I'm pardon me if I'm going very slow, and and pardon me if I'm very technical also. So the warehouse is approving the blockchain, yes. Then master ledger approves this blockchain, I say yes. The mother hub approves this blockchain, I say yes. Okay. So before I go ahead, don't say this thing. Before I go ahead, when somebody is proposing something to add to the blockchain, okay, there are 3, 4, 5 organizations who are voting for it. Is this voting happening in the real time? What time does it take? Okay, chalo, we will discuss in the proof of work or in the consensus algorithm. But let me tell you right now that it is happening simultaneously. Once, like the organizations are different servers or nodes who are up in different geographical location of the country. And when I propose this proposal goes to every one of them electronically through the network. If the network is fast, it is happening very quickly in the real time. And in that organization, here I am typing yes. But that organization may be running its own checks and balances. Okay, own checks and balances in their own script. They may be having some script. This is authorized or not, this is good time to add or not, this is probably signature of puff, signature or something of that, that this is verified or not. He will verify all these things and then he will say, yes, it is approved from my side. Okay, are we all understanding this? Or I'm very slow or fast? Okay, good to go. So it is happening in the real time in the network, and then that blocks, if everybody says yes or the consensus is achieved, which we will see later how it is achieved, we will talk of it. So, the block will be added to the blockchain. Okay, so here now you can see, are you following my cursor? Here it reads propose update organization mother hub item Wi-Fi add action 1 quantity 1. So warehouse said okay, yes. Master ledger approves this block, yes. Mother hub approves this block, yes, because all these three were the organization who were having ledgers. Okay, so they approved, and consensus result, warehouse yes, master ledger yes, mother ledger yes, and block added to all ledger successfully. Got it? Now let us see at this very time that what is the present state of the blockchain. Okay, so I go to the menu 7 and I press it. Now you can see 7 blocks. Can you follow my cursor? Yeah, so this says block 7. Why this is block 7? Because while I started with block number 5 or 4, and then I build upon it. So this is, I have made one entry and this has been updated. Okay, good to go. All with me till now. Okay, so now we'll see each block, that what each block contains. Okay, so this if you see this block number 5, I am talking of block number 5. It has some timestamp. What is the timestamp? What do we mean by timestamp? That yes, at this very time this block has been created. Previous hash. What does previous hash means? What does previous hash means? What could previous means? In the fifth block contains hash of the 4th block. Whatever thing is there in the 4th block, is its hash has been calculated, and that hash has been stored in the next block. Now if somebody will modify this 4th block, he will have to change the hash in the 5th block. And now when somebody will modify the 5th block, he has to change the hash of 5th block in the 6th block, and so on and so forth. Okay, so this is how we say that blockchain, it is immutable. Why immutable? Because if I will change one block, I will have to recalculate the hashes of each block, which is actually very tedious and very time consuming and not practical. Are we at common consensus now? Okay. So now let me do one thing. Now I told you that we have 3 organizations, mother hub, warehouse, so, and each of them are having their ledgers. Now let me show their ledger. And let me modify one odd entry or data or something in the ledger, and then we see that how blockchain behaves. Okay. So I have exited this. Okay, so if you follow my cursor, this is master ledger. This is the master ledger of master ledger entity or organization. Okay, so I can change anything here. Let me go to the last block and modify the state of Wi-Fi. Okay, so it says here Wi-Fi, and I make it 5. Okay, I have changed that ledger. So I am a smart person. I have gone to the master ledger database of it, and I have just changed the master ledger. But when the blockchain will boot again, it will again perform what? Recalculation of the hashes, integrity checks. when we had started the lecture, integrity check was performed. So again, when the blockchain will start, it will perform the integrity check. So when I run that blockchain again, it says performing integrity check failed for master ledger.js. Okay, because it has recalculated all the hash, matched all the hash with each other. Now it says some ledgers are corrupted. Would you like to perform self recovery? So I say yes. And what would it do in self recovery? It will. What? Yeah. Get back to the past version, or it will again take a consensus. All those are good ledgers. If say suppose 70% of the ledgers are good ledgers, it will take a legible copy of that, and it will. Yeah. Okay. Everybody with me? I'm overshooting time. I'm good to go. So it says now, if you follow my cursor, it says some ledgers are corrupted. Would you like to perform self recovery? I said yes. So picked the majority 2 matching copies. Replace the corrupted file with that correct version. All ledgers are restored from consensus copy. Normal execution can continue. Okay. Hope you people are understanding. Okay. Now, let me talk about consensus. So what is consensus? Blockchain has 2 main things. One is your hash, which I started with, and the second thing is consensus. I don't have any slides, but I have some points what I want to tell you, and then we'll just talk of it. Okay. So what is consensus? Can somebody tell me what is consensus? Okay, reaching to a common conclusion, if I may say. Say suppose I divide this entire class into 2 different teams, and I say that it is a quiz. Okay, tell me what is 2 plus 2. Somebody will say 3, somebody will 4, somebody will say, I will say, okay, do one thing. Each class to choose a leader, and that leader needs to tell me what will happen, what is the answer. So you discuss amongst yourself, reach to a common conclusion. That is called a common consensus, and then that leader tells me that okay, this is my final answer, I record that answer. So that is what consensus is. Okay, so there are many types of algorithm which is being followed for consensus. So I'll be covering 2-3 of them. The first one is proof of work. So what is proof of work? Can somebody tell? Okay, yeah. Correct. Okay, you are on the correct line. Good. So it is followed. Proof of work is followed in bitcoins. Okay. What happens that whenever a bitcoin, now I will tell you a brief about bitcoin. Like in a bitcoin, say suppose we all are having bitcoin, and we are not trading in rupee, and we are not giving rupee to each other, we are giving bitcoins. So say suppose I am giving some bitcoin to someone is giving some bitcoin to somebody. So that the entire transaction is recorded somewhere, and that transaction has to be then included in one chain, one block of a blockchain, so that it is now recorded in the ledger. Okay, but now everybody, thousands of people are making the transaction, and we have a block ready. Okay, say suppose we have a block ready to be added to the blockchain. Who will add that block to the blockchain? How will we delegate that responsibility to someone, or how will we come to know, how will we choose someone that you are the right or legitimate person who will add to the blockchain? In Bitcoin, it is done by proof of work, whereby I say, okay, this block is ready to be appended to be added to the blockchain, but every one of you can add it, and you will get, say suppose, one bitcoin, it is too much. I'll say suppose I'll talk in rupee. I will give you 100 rupee to add this blockchain to the block. You all will compete. You all will say, I want that 100 rupee, I want that 100 rupee. So I give you a mathematical problem. Okay, I tell you that okay, whosoever solves 2 plus 3 is equal to what? He he will get the chance to append that block to the blockchain and he will get that money. Now what that problem is, that problem should be sufficiently strong, okay, hard, so that it will take time, it should take time to calculate that. So what challenge is given in Bitcoin? You have to, when you have that block of blockchain ready, you have to calculate the hash of that blockchain in such a way that it has some pattern, like 10 numbers of leading zeros. Are you understanding? Am I going too technical for you to second year guys? Okay. So I calculate the hash of the entire block, but hash of the entire block cannot be, if I calculate hash of a block, hash will be for the entire block, hash will be unique thing, but I want that hash to be like something leading so many zeros. So I have a field called nonce. So I change that field, and by hit and trial, keep on changing, keep on finding hash, keep on changing, keep on finding hash. By hit and trial, I try to find the legitimate hash for which I will announce to the network that I have got the hash. Okay. So this is what proof of work. So what is at stake here? Say suppose you all are competing to find the hash, but only one will find. So like what others will lose? Yeah. Energy, computational power, yes, because you have been working like you have been working for, say suppose in entire year you will earn 4 lakh of rupees, but say suppose you are not able to crack find that hash, so your energy and time, that electricity, that wear and tear of a hardware, everything is at stake. So this is what is followed in the Bitcoin. Ma'am, am I good to go? Okay. I have 2 more algorithms cover, 5 minutes more. Okay. Second is proof of stake. Yeah. So what is proof of stake? Yeah. Okay. So I say in proof of work, my own computational power, my electricity, my own this thing was at stake. If I am not able to find the solution, my entire effort will go for a 6. Okay. What happens in proof of work? How the consensus is achieved? Okay, there are 3 ways to earn money, to become a billionaire. Firstly is you work very hard and you become a billionaire. It is by the first algorithm, proof of work. You work hard, get money, and become a billionaire. Second is you inherit money. From a father, you inherit money. Okay, that is what it is in proof of stake. And third is you marry a rich guy. Okay, so we'll not talk of that. So proof of stake. So what I do, I say that okay, I have 1 crore rupee, 32 Ethereums. I put that 32 Ethereums at stake. And for that 32 Ethereum, I am now an authorized. I am authorized to, propose the block to the blockchain. It is all probabilistic. Say suppose there are 10 of the people who want to propose the block, and everybody has put, say suppose 1 lakh rupees each. So everybody has 1/10 of probability that he will be allotted next slot to propose. Okay. Got it? Like this is simple probability. So 1/10 of block I will propose, and I will get 1/10 of the total reward. So like in Ethereum network, generally presently one proposer, he gets around 4 lakh of rupees per year. If he has put 32 Ethereums at stake. So this is, now here what is at stake? His money is at stake. If I am a wrongdoer, if I am not proposing the right, I am counterfeiting something, I am changing the fields, I double spending means if I have given some money to someone and again to someone and I am signing it and proposing that block, that then I will be penalized. My Ethereum will be, which is at stake, will be cut. So that is what it is, proof of stake. Then third is the, then there is proof of delegation also, whereby it is same like proof of stake, but I don't want to do this thing, but I have money, so I delegate someone. Just like in election, I choose someone, so and he will keep on doing on my behalf, and when he will get money, he will just distribute to all those people. So if I don't have 1 crore rupee, I have 1 lakh rupee, so hundreds of 1 lakh rupee will become, will make 1 crore, and hundreds can choose one delegate and he can participate. So this is what proof of delegate is. Then third is Byzantines. Yes, correct. So, you know, what it does, it is just like a common consensus when there are 10 organizations which is proposing one block to be added to the blockchain. So it takes a consensus. Okay. And if more than 2/3 of them say yes, the block is legitimate, it is appended to the blockchain. Okay. So I believe that like you learned something from this short demo and this short talk of me which I had with you. Any questions in this part? That, yeah, so actually the thing is that it says the formula is, if you have I will tell you a small story. Like the story is that if king wanted to go for a war and he had some generals, some were unfaithful to him, and he used to say that if majority of my generals will say attack, I will attack, or if majority will say retreat, I will retreat. And but there were some unfaithful generals. So the king found the formula that if my generals are 1/3, if there are F generals who are unfaithful and total number of generals are 3F plus 1, then I will attack. So it roughly comes to 2/3. But yes, it depends on you. It depends on you that how you want to make this algorithm. I can say that my blockchain should be such that each and everybody should say yes, then only I will add this. Or I say that if at least from 10, at least even if 2 says, I will add it. So actually the algorithm is on you to design. It depends on your requirement. This is a basic set, these are the basic set of rules, but you can always tweak it. Okay, so that is what it is. So I would now request my colleagues to please present some demonstration which they have planned.
Have you introduced yourself?
No,
So, yeah. So he's now a student in our department, but he is basically every year we get few people from
ये लूप नहीं, ये ब्लर आ रहा है किसी तरीके से, नहीं आ रहा। पता नहीं, अभी क्या ज्यादा क्लियर है नहीं। Okay, so you already know about the puff, and basically they are used for the authentication of a device, and it is because every device hardware has some intrinsic properties that change when we change the device. Okay, so for real life you either required a ASIC device or a FPGA to implement a puff, and if you don't have either of them, you can simulate them, and there are some developers that give us the module of PyPuff. Basically you can easily install them in your device by a simple command pip3 install PyPuff, and they get installed in your system, in your device, and then you have to import them as any other Python module. Okay, so the first thing we are going to do is basically create a single bit arbiter puff. Every one of you know about the arbiter puff? All of you? Okay. So what the arbiter puff is, it has a chain of muxes that take a single bit challenge. Each mux take a single bit challenge. So here basically what we are doing, we are creating a arbiter puff that has a 64 such muxes. Okay. And this seed parameter is used because so basically how the arbiter puff is works, it has a delay chain of each wire, and that wire delay is basically a random number. There is a random delay associated with each wire. So to simulate that delay, we need a seed. So if I change that seed to 1, it will initiate one delay chain with one set of random delays throughout the puff, and we can actually change that seed to 1, 2, 3, any random delay, and it will create different instances of the puff, because each puff has a completely random delay based on that seed value. So here I am creating a puff with a 64-bit chain. Now the second thing we have to do, we have to get some challenges. Okay, so either you can create your own challenges, or you can use this particular module where you give how many challenges basically you want, and this is the seed or the random number for what like how the challenges are generated. So we are generated the random seeds, random challenges. For that we required a random seed, and we store these challenges in some module, and here I am printing the challenges. So each challenge look like this. Here I am creating the 10 challenges. I am only printing the first one, but if I want to print all the challenges, this is how all the challenges look like. Here -1 represents the 0 and the 1 represents the 0. It is in the real 1 represents the 1 itself. So it is done because when we are modeling this puff in the simulator, we have to create some equation, and it's easy for us to represent the 0 as -1 because it required some multiplication operation and other operation, and it's easy to perform that operation with -1 and 1 instead of 0 and 1. Nothing technical about that. So here we create the challenges. Each challenge look like this, and each challenge is of 64 bits. Okay, now we use the puff eval function. We feed that challenge to our puff, and we get a single bit response. And here I am printing the single bit response, that is the 1. Okay, and if you want to see all the responses, I just have to do that. So these are the responses for the 10 challenges that we have created initially. Okay, any doubt? Now there are the 3 properties that are associated with the puff. First one is the uniformity, second one is the reliability, and the third one is the uniqueness. Okay, are you aware of these properties? No. Okay. Okay. So basically we are feeding a challenge into a puff, and it will return a single bit value, either a 0, either a 1. Now what will happen if for any challenge it will only return us the 1, then that puff is not useful, because an attacker can simply say, okay, no matter what the challenge is fed it to that puff, it always returns the 1, so I will just pass it to that. So the authentication can be broken using that property if it does not follow the uniformity. Same will happen if the puff is skewed to the one-sided, like if it gives 90% of time 1 and only 10% of time 0. Then also the attacker can say, okay, maybe there is a chance that the probability that the response of this particular challenge is 0, but the chances are very less. So why not I can go with the probability and I just can feed the 1, and there are high chances I can pass the authentication. So for an idle puff, the uniformity should lie between the 50%. There are 50% chances that the response comes out to be a 0, and the 50% chances the response should come out as a 1. Okay? So here what we are doing, we are creating 10,000 challenges. We are feeding these 10,000 challenges as into the puff and getting their response. Okay? So this is a single bit. So here I am only printing only print the 2 challenges, 0 and 1, and I only print the 2 responses. From smaller data, it look like it always give the 1, but when we enlarge that data, suppose for 100 responses, you will see there is a complete random pattern. 1, 1, minus 1, 1, minus 1, then there are 3 ones, minus 1. So now to find out what is the uniformity, we take this array, we basically calculate either how many minus 1s are there or how many 1s are there. Suppose we feed the 10 challenges, out of which 4 will come as a 1 and 6 will come as a minus 1. So the uniformity will be 40%, 40 or 60, whatever you take. The idle value should lie between 50%. So when we increase the challenge, like for this particular case, I count the number of 1s of all the responses I am getting using this formula. Simple, we have to count number of 1s, and I am getting the uniformity of 50% in this case. If I initialize it with some other puff, like for seed value 7, maybe the uniformity will differ. Now in this case the uniformity is 49%. Okay, ideally the uniformity should lie close to the value of 50. Any doubt in that? Okay. The second property is the uniqueness. Suppose you created a function puff. Puff is, if we treat it as a function, what will happen when you feed a input to that function? It will return us the value. In normal function, the return value should always be same, but not with the case with the puff. What will happen if all the puff, no matter who created them, where they are creating, when we feed a fixed challenge, they will give us the same response. Now what the attacker will do, it will create the puff on its own, and there is some valid puff, and when it comes to the time to the authentication, the same challenge come to the real puff and the fabricated puff, and both are giving the same response, right? So then also the authentication can be bypassed. So can anyone tell me what would be the value of the uniqueness? Then if you feed 10 challenges, how many times you will get the same response and how many times you will get the different response? Any idea? How much? No idea? Okay. So if I say that my puff is 100% unique, is that good or bad? Good or bad? Yes or no? Anyone can say. Huh? Good? Technically it is not. Because once the attacker will know that for that one particular challenge, my puff will give a response and it is always the inverted response of the valid puff, then it can simply use a NOT gate. So technically the uniqueness of a two puffs should be 50%. So here what I am doing, I am creating two puff, puff 1 and puff 2. I am giving them some random seed and I am taking 1 lakh challenges. It's 1 lakh challenges, feed the same challenges to the same puff, same challenges to two different puffs and get the responses. So here I am getting the responses. This is the response from my first puff and this is the response from my second puff. Okay. Now I will match how many of the elements between these two arrays are same and how many of are dissimilar. And then I compute that okay, my 50% of the elements are matching when I am giving the same challenges. 50% of the time the challenges are responses are not same. So I can say my uniqueness is nearly around 49% in this particular case. Okay, any doubt in the uniqueness? Okay. Now the interesting thing about the hardware is that it will not perform well when we change the environmental factors. That gives the third property of a puff, that is the reliability. That if there is a single puff and if I feed a challenge, it will always give me the same response. If it don't give me the same response, it give me some random response, then I am not also authenticate my real device because I don't know what the response is. And in practical, the responses of the puff may get vary when we change the environmental factors. This is due to because the puff is based on some resistivity property, the arbiter puff, and resistance may change, or I can say the physics taught us that it can change when we change the temperature or the pressure of an environment. Okay, but here we are just simulating the puff, so we cannot it always give us the same reliable result. So what the developers do, they give us another parameter that is the noisiness. The value of this noisiness varies between 0 and 1. The 0 means that the puff will always give us the same result, that there is no change in the environmental factor, and 1 means there is a complete change in the environmental factor. And you can change, you can vary this parameter to find out, to check your protocol against different reliability in the real condition just by the simulation. That okay, the variance in the environmental factor is that much, so I give the noisiness values to that particular value and then I check the reliability of a one particular puff that I have created. So here what I am doing, I am also already creating a puff, same puff, arbiter puff. I give the noisiness factor as 0.5, means there are 50% chance that the environmental will vary. I generate some I only need single challenge now. Now what will I do? I give this challenge to that puff again and again and again and again. Okay, and I get the response. If I say that my puff will always give me the same response, then I can say that this puff is reliable, no matter what the environmental factor is. But as we can see here, there are some ones in that responses. There are some minus ones and there are some ones. So how I calculate the reliability is I calculate what is the majority voting. That okay, -1 is coming the most number of times, so it is the correct output. Now I find out how many times -1 is not coming. Okay, in that particular case my puff is non-reliable, so I deduct those cases out of the total cases and I get the reliability percentage. Here the reliability percentage is 94.75. It will come something else if we rerun this, because these parameters keep on changing. Suppose I am creating another puff with some another random seed. I keep the noisiness factor as fixed, and it takes some time here. Now the reliability will come 88%. Okay, any doubt?
Please understand that this is just a simulation. Otherwise, the power is previous function, they are not at all software. Okay. Just for understanding of the properties, we have in this simulation.
Now let's create a protocol, a very basic protocol. Yeah, this is the last protocol. ये mic चाहिए आपको?
So we have discussed the three different properties of puff. Now we'll discuss like how we can use puff in authentication some devices, like whether that particular device, whatever device I am having is actually valid or not. Okay, so that validation how we are going to do. So for this we have created puff instances here. Okay, and we have write down this script, and we have first of all we have created a puff devices, and then we have created two different puff devices, and in the database we are first creating some n number of challenges and capturing responses for that n number of challenges. Like for example, I'll take an example to make you understand. Let's say I am a valid company and I am developing a device, or I am creating a device and selling it to the market. So before selling it to the market, I'll create this that particular device and collect challenges here, create a puff out of it, and I'll create some challenge and response pair, and I'll save it to my database. So that if someone unauthorized company come and try to replace my device, that device's property, physical properties of this puff should match my database actually. Okay, so we have created let's say two devices. So here device 1 is a legitimate one and device 2 is the illicit one, or it is not a proper device. Okay, so here we have in the setup phase. Setup means creating those challenges and response pair and setup and stored into our database. So in the setup phase, we have already done a setup for our device 1, and we have collected all challenges response pair and stored into our database. So this is how our challenge and response pairs look like. Okay. So now for let's say for validation, when it comes for a validation, you can see we have validated both the devices, but for device 1 the authentication successful, device 2 authentication failed. This is because puff devices is basically used for the responses of puff device will vary even if the response is same, because of this reliability factor. Okay. So and there are some environmental noise and all these things. So this is why even if the configuration and everything is same for two different puff device, the response is going to vary, and this is how we are going to authenticate whether the particular device is coming from a legitimate source or illegitimate source.
So I think that's also our side. So today we have learned that what is IC supply chain and what are the different stakeholders there supply chain, and from there we have understood what are the attacks that can happen to introduce counterfeit ICs or old ICs into the supply chain, and can create a lot of loss for the industry, semiconductor industry. Then we have found out that how we can use inherent property of the hardware itself to create a fingerprint, for authentication of the real chip, and then how this challenge response pair databases can be integrated with the blockchain to make a smooth authentication across all the stakeholders, so that we can stop counterfeiting ICs in the IC supply chain management system. That's all. Okay, thank you very much. So there will be a paper discussion session. I think I have shared two research papers. One that we have just discussed, it was earlier shared, and then there was an old paper as well, which is kind of a literature survey. Have you guys gone through it? एक बार हम शेयर कर सकते हैं हम लोगों से तो हाँ
So there will be a 10-minute break. Today your lunch will be delayed after this session, right? Upcoming session, then we'll go for the lunch, right? So now you can leave for
paper only, right? And the presenter was just reading or showing some highlighted part, right? Something like that. Okay. आज ऐसा नहीं करेंगे.
The faculty summarize all the paper and the problem solution and how we tackle and what are the sort of things we will tackle during those papers.
So today we have already explained the summary of the paper, one of them, and the second one that I sent, it was this one. This one is mainly a survey paper, okay, or a basic understanding of how blockchain structure can be used for IC supply chain management. Today, let us do something else. Why do you need to read research papers? Let's discuss that. So you guys are BTech students, right, mostly? Why do you need to read a paper? What do you think?
Ma'am, to identify the flaws, to identify the modifications, what we can do to get more better in the research.
Yes. Not only for research, even if you... Can I use this one? Yes, can you hear me better? So, not only for research, but for any kind of reference or to find out that what new you can do. Okay, so I am going to tell you how do we do research. Okay, so always you go to this website first. It's Google Scholar. Just a second. Yes. So whatever is in this whole world is getting published, be it physics, chemistry, computer science, electrical, all are getting indexed in this. Google Map पता है, Google Meet पता है, Google Scholar कितने लोगों को पता था? Good, very nice. ठीक है? तो अब suppose today I want to know that what are the research papers that are coming on hardware supply chain management plus security. So what you will do, you will just write the keywords. Okay, IC, oh I did it basically, IC supply chain plus security. You will get the topmost cited papers and also the rest. I mean not like this one is more cited one. You will get a whole idea about the recent state of the art on these papers. Okay. Now if you want to even see that what are the very recent paper, you can also select this since 2021. You can also select since 2024. Okay, so here you will get last 3 to 4 years top cited useful papers. Okay, now there is another thing I want to show you is not all research publication venues are good, because we are talking about research papers, no? So I thought it is very important for you also to understand which venues to look for. There are some particular venue and they come under IEEE also, where you can publish your paper with giving money. So you will pay money, it will be open access, whatever garbage anybody is writing, they hardly get reviewed. Within 3 months your paper will come online and they will be literally garbage. So what are the papers or what are the venues that you should look for? Okay, let's see that and how you will find your area of interest. Okay, so let me go back somewhere. Yeah, so because I work on hardware design and security and all, for example, if I want to see what are the good venues in cryptography and security, this is the rank that is given by Google Scholar. Okay, so this is the current top 20 venue, which can you see the names? Okay, so depending on this some metric like H5 index and H5 median, they will give you the current top 20 best places in cryptography and security. Now sometimes what we have is that we are mainly many of us are specialized in cyber security, some in network security, some in hardware security. The top places takes paper from every dimension of security and privacy. But still, for example, like this is a particular place, we call it TCHASE, Transactional Cryptographic Hardware and Embedded System. You talk about side channel security, this is the place. So little bit of more knowledge you can gain once you go deep into the research. But overall, to understand that what are the good venues from which you can actually get latest up-to-date work on a particular domain, please do this screening in Google Scholar. Let's see another example. I also work on, because I work on hardware design, so many hardware design conferences are also good where hardware security paper gets accepted. For example, TCAS 1 is a transaction, IEEE transaction, but they mainly focus on IC fabrication papers. So if you have a design and you make a fabrication out of it, go for this one. Okay, for us, we try to publish in IEEE transaction on computers. Okay, we try to publish in IC-CAD if somebody is doing on CAD tools or in any kind of verification thing. Date, DAC. Okay, so for example, there is a particular, don't think that I am discriminating. There is a journal by IEEE IoT journal. It publishes anything and everything in IoT, from computing to networking to security to architecture, right? So it's very dicey. It's very dicey. Every transaction or a conference has a program committee or editorial committee. Okay, if you are accommodating so many topics in one but under a single umbrella, okay, you know the quality will degrade. Because today I become the part of the committee of editorial board of IoT journal, I will get a networking paper, I will get a performance paper, I will get a security paper, but will I be able to do justice to that networking or a performance paper or a machine learning paper? In IoT we can also implement, we can use machine learning and AI, right? Okay, so you have to be very, very careful which material you will consume from internet. That is the first, that is more important than reading a research paper. That which research paper you should read. Okay, so because you guys are in computer science, so if you go to this engineering and computer science, so lot of categories you will get. Okay, so you can select those categories and then from there you guys work on machine learning and AI. सब काम करते हैं आजकल. एक टॉप कॉन्फ्रेंस का नाम बोलो तो. अगर आज तुम्हें देखना है कि इस सपोज तुम एयर क्वालिटी मॉनिटरिंग में कुछ देखना चाहते हो कि कहाँ पे पेपर छाप रहा है, क्या पेपर छाप रहा है. डू यू नो एनी गुड वेन्यूज ऑन machine learning and AI? This is bad. So there are something called AAAI, NeurIPS, ICML. These are the venues from where you should actually check papers on machine learning and AI. Okay? Okay. So, so next time when anybody will come on talking about any topic, there and this research paper discussion session goes on, फर्स्ट यू ट्राई टू फाइंड आउट कि इस तरीके का पेपर कहाँ पे अच्छा निकलता है, ठीक है, एंड देन ओनली रीड फ्रॉम those things. But generally IEEE transactions, ACM transactions and few very good conference venues are good enough to start the research or to look into the state of the art. ठीक है, वो मलेशियन कॉन्फ्रेंस उसमें क्या होता है देखोगे 300 साइटेशन है. वी ऑल्सो गेट लाइक लॉट ऑफ ऑस्ट्रेलियन कॉन्फ्रेंस में पेपर छापते हैं पर उसका क्वालिटी अच्छा नहीं होता है. तो डोंट फॉल फॉर दैट दोस ट्रैप. ओके, यू विल थिंक दैट ओके मैंने एक कॉन्फ्रेंस पेपर छाप लिया बट नोबडी विल रेस्पेक्ट दैट. ठीक है, गुड. अच्छा, तब बोलो लेट अस. सो हैव एनीबॉडी गॉन थ्रू द पेपर येट? नो, गुड, डोंट. Okay, so let us see this paper because we have already discussed this diagram हमने discuss किया था, right? तो ये कोड तुम लोगों को GitHub में मिल जाएगा. You can actually simulate the whole framework, okay? And then what we did that time, because it is little bit old paper, it's a 2021 paper, we have actually implemented this path design that we are again and again talking about in something called FPGA. Do you know FPGA, the name FPGA? No. FPGA is field programmable gate array. So whenever I have a hardware design, अब हार्डवेयर डिजाइन का मतलब तुम लोगों को क्या समझ में आता है ये बताओ पहले. What do you understand when I say hardware design? ASIC design, circuits, circuit diagram. Okay, so today if I say that I have an algorithm factorial n, can I create a hardware for that? सोचो तो. Do you have a marker? Think before you speak. Can we make a hardware of factorial n? कैसे बना सकते हैं? सर्किट डायग्राम से, मल्टीप्लायर से. हैज एनीबडी हर्ड दिस टर्म मल्टीप्लायर? हमारे कंप्यूटर में है मल्टीप्लायर. अरिथमेटिक लॉजिक यूनिट में मल्टीप्लायर है ना. तो जब हम एक्चुअली लिख रहे हैं कि फैक्टोरियल n is equal to n into n minus 1 into 1, इसका हम सॉफ्टवेयर कोड लिख रहे हैं पर एग्जैक्टली हो कहाँ रहा है n into n minus 1? ALU में हो रहा है. ठीक है, तो ALU is a general purpose hardware. वो गेम भी खेल सकते हो तुम उसमें, तुम नोटपैड में लिख भी सकते हो, तुम बहुत लंबा एक मल्टीप्लिकेशन भी कर सकते हो, तुम सब कुछ कर सकते हो. Sometimes we create dedicated hardware for a specific purpose. For example, I want कि मेरा कोई एक एप्लीकेशन है जहाँ हमेशा ये फैक्टोरियल n यूज होगा, तो will I involve a whole computer for that? No. क्यों मैं 1.5 लाख का कंप्यूटर लूं उसके लिए, right? So what I can do is that if I know what is the maximum value of n, then I can know what is the maximum value of factorial n, right? So for example, if my maximum value of n is 5, then what will be the factorial of n 120, and how many bits are required to represent 120? 7. And how many bits are required to represent 5? 3. So what I can do, I can create a 7-bit register. ठीक है, अब मैंने क्या किया, मैंने n लिया, राइट? अब मेरे पास एक मल्टीप्लायर है. I reduce the value by 1, multiply किया, write it here, reduce the value by another 1, इसमें multiply किया, add किया. Okay, so what I need 2 3-bit register, 1 multiplier and 1 7-bit register given the size of n and factorial n, and I create a hardware. मुझे इतना परिश्रम करने का जरूरत नहीं पड़ेगा. Okay, so I can actually fabricate a chip for factorial n as well. Okay, तो हमने we did now there is 2 more thing I just want to let you know, that there is, we can create a ASIC chip for this. ASIC means application specific integrated circuit. So this chip will only do factorial. Okay, and then there is something called FPGA. FPGA is also an ASIC chip, but in the FPGA there is a programmable part, programmable by the user. यहाँ पे हम कोई भी हार्डवेयर को रियलाइज कर सकते हैं. अब तुम बोलोगे मैम ये तो गेट से, हम लोग तो मल्टीप्लायर भी होगा तो वो तो कुछ लॉजिक गेट से बनेगा, तो फिर पहले मैंने एक फैक्टोरियल का यहाँ पे बिट फाइल एक फाइल लगा दिया, उसको फिर मैं नया डिजाइन कैसे दूं? कल अगर मुझे फिबोनाची सीरीज प्रिंट करना है, उसका हार्डवेयर बनाना है, तो मैं कैसे करूंगी? बाय द वे, फिबोनाची सीरीज का हार्डवेयर बना सकते हैं कैसे? फिबोनाची सीरीज बनाने के लिए हमें कौन सा लॉजिक यूनिट का जरूरत पड़ेगा? ऐड से ही हो जाएगा. ठीक है, तो 2 वैल्यू लेंगे और एक टर्म के लिए n लेंगे, तो 3 रजिस्टर, ऐड करो प्रिंट करो, ऐड करो प्रिंट करो. ठीक है, तो हम क्या करते हैं FPGA में, बेसिकली हम गेट लेवल इंप्लीमेंटेशन ऑफ द हार्डवेयर नहीं करते हैं. FPGA में जो ये प्रोग्रामेबल पार्ट होता है ना, इसमें रहते हैं SRAM. व्हाट इज SRAM? स्टैटिक रैंडम एक्सेस मेमोरी. ठीक है, वी इंप्लीमेंट द ट्रूथ टेबल ऑफ द लॉजिक. अब मेमोरी को तो हम बार बार रीड राइट कर सकते हैं, दैट्स व्हाट वी डू. तो पहले लॉजिकल वेरिफिकेशन के लिए वी यूज FPGA कि लॉजिकली हमारा कोड सही है या नहीं, by implementing the truth table of the logic. And then once I know that okay, my design is working good, then I will go for an ASIC implementation. ठीक है, good. So because this is a simulated thing that we did, our code works with the FPGA. The green thing is an RTX 7 FPGA where we implemented our PUF circuit. ठीक, अब सोचो कि ये Xilinx का FPGA है. ठीक है, अब मैंने क्या किया, 10 लाख Xilinx FPGA बनवाया है. ठीक है, अब somebody is trying to counterfeit it. I will implement a PUF inside it. And while exchanging this FPGA from one stakeholder to other, I will actually authenticate this FPGA using the PUF circuit. So that was the whole point of setting up the whole auto PUF chain code using blockchain plus FPGA. ठीक है, अब फिर से भूल जाओ पेपर के बारे में. जब ऐसे एक डिजाइन होगा, तुम लोग जब पेपर लिखोगे या तुम लोग जब कोई नया प्रोटोटाइप बनाओगे या कोई भी एप्लीकेशन बनाओगे, तुम्हारा एप्लीकेशन अच्छा है बुरा है ये कैसे इवैल्यूएट करोगे? जोर से बात करो. Yes. So we have to evaluate our system with respect to some metric, right? तो जैसे कि अगर फॉर एग्जाम्पल हम ये दिखाना चाहते हैं, हमने एक सिस्टम डिजाइन किया है कि अगर मेरे पास एक स्वार्म ऑफ ड्रोन्स है तो उसमें वी विल स्टॉप DDoS अटैक. डिस्ट्रीब्यूटेड डिनायल ऑफ सर्विस अटैक, ठीक है। तो उसके लिए हमने एक काउंटर मेजर बनाया है। अब तुम इवेल्युएट कैसे करोगे? रैंडम, आई एम जस्ट टेकिंग अ रैंडम एग्जांपल। पहली बात तो ये है कि जब तुमने काउंटर मेजर इंप्लीमेंट कर दिया है, तब फर्स्ट यू विल ट्राई टू डू DDoS अटैक। हाँ, और देखोगे कि DDoS हो रहा है या नहीं हो रहा है, या ये लोग मतलब दे आर गोइंग टू अनदर लेवल, ताकि डिनायल ऑफ सर्विस हो ही ना, ठीक है। सेकंड क्या टेस्ट करोगे? कितना टाइम लग रहा है एक ड्रोन को अंडरस्टैंड करने में कि DDoS हो रहा है, ठीक है, क्योंकि दिस इज इंपॉर्टेंट, राइट। DDoS होने से पहले ही अगर जो अटैकर है उसने इतना सारा सर्विसिंग करवा लिया ड्रोन से कि लेफ्ट में जाओ, राइट में जाओ, टॉप में जाओ, नीचे जाओ, योर बैटरी इज डाउन, ठीक है। तो अगर DDoS हो रहा है ये समझने में उसको 10 मिनट लग गया, तब तक तो पावर गया। सो डिटेक्शन टाइम और एग्जीक्यूशन टाइम ऑफ योर काउंटर मेजर, ठीक, और देन how long it can hold until the attack is circumvented, या the moment it will get detected कि अच्छा DDoS हो रहा है, what are the steps that they are taking to let the ground control station know कि DDoS attack हो रहा है। वो कितना effectively, given कि DDoS शुरू हो गया है, मेरा network is getting fooled with bogus requests, so how efficiently I can let my ground control station know कि there is a DDoS attack that is happening, so either jam the channel or do something else, ठीक है। So whenever you write a research paper or you look into different research paper, the first is the purpose of the paper, second is how they have proposed the attack model or proposed any methodology, third how they have evaluated it, ठीक है। बहुत सारे पेपर, जो खराब पेपर है उसका एक्सपेरिमेंटल सेक्शन देखना एकदम छोटू सा होगा, इंग्लिश में कुछ लिखा होगा, ठीक है। कोई भी प्रॉपर मैट्रिक्स, प्रॉपर कंपैरेटिव स्टडी विद द स्टेट ऑफ द आर्ट नहीं दिया होगा। इट्स इजी टू राइट समथिंग बट इट्स वेरी डिफिकल्ट टू एग्जीक्यूट इट, ठीक है। सो फॉर एग्जांपल व्हेन वी टॉक अबाउट एनी सिक्योरिटी पेपर, वी सी दैट हैव दे बिल्ट अप अ टेस्ट बेड टू वैलिडेट देयर वर्क और नॉट, ठीक है। So when you go with this auto pufferation paper, you will see that there is a entire end-to-end implementation of the blockchain associated with puff, okay, and then there are execution time result, memory कितना लग रहा है, IPFS में data storage का impact क्या है, all those information will be there, okay. So I think that's it. Because we have actually explained the paper very well in our talk, I don't want to hold you. Lunch time is there. Read good stuff to do good things. That's it. Okay? Thank you very much.
Thank you so much, ma'am, and esteemed speakers for such an enlightening and insightful session. Your words have truly broadened our understanding and given us a deeper perspective on today's topic. We are extremely grateful for the time you took out of your busy schedule to share your valuable knowledge with us. Now, I would like to call Head of CSAIML Department, Dr. Nancy ma'am, to present the memento to our esteemed guest. Your session has not only enhanced our technical understanding but also inspired us to explore further in this rapidly evolving domain. Once again, thank you, ma'am. Guys, give a huge round of applause.